What is differentiation? Differentiation is a process in calculus used to find the rate of change of a quantity or the slope of a function at any point. The result of differentiation is called a derivative. It helps us understand how one quantity changes in relation to another.
Technique of differentiation. The first one is rules of differentiation. The first rule is constant rule. d over dxc equals to 0. The second one, power rule. d over dx, x power of n equals to nx power of n minus 1, and d over dx, ax power of n equals to n ax power of n minus 1. The third rule is sums and differences rule. d over dx, fx plus minus gx equals to f prime x plus minus g prime x. The fourth one is product rule. fx equals to ux, where ux and vx both exist. Then d over dx, fx equals to uv prime plus vu prime. The fifth rule is quotient rule. If fx equals to ux over vx, where ux and vx exist, then d over dx, fx equals to vu prime minus uv prime over v squared. The sixth rule is chain rule. If y equals to fgx and u equals to gx, then y equals to fu. So dy over dx equals to dy over du multiplied with du over dx. Simplified version is d over dx, fx power of n equals to n fx power of n minus 1 multiplied with f prime x. Derivative of trigonometric function. Sin fx will be cos fx multiplied with f prime x. Next, cos fx going to be negative sin fx multiplied with f prime x. Then, tan fx will be secant square fx multiplied with f prime x. Cosecant fx would be negative cosecant fx cot fx multiplied with f prime x. Then, secant fx would be secant fx tan fx multiplied with f prime x. And for the last one, cot fx would be negative cosecant square fx multiplied with f prime x. Next, derivative of exponential function. In general, d over dx e power of fx equals to e power of fx multiplied with f prime x. For the simplest form, when fx equals to x, d over dx e power of x would be e power of x. Then, for derivative of logarithm function, in general, d over dx ln fx equals to f prime x over fx. But for the simplest form, when fx equals to x, d over dx ln x equals to 1 over x.
Question 2. Find dy over dx for the following functions. For question A, y equals 4x squared cos 5x minus 2. To differentiate the function, we recognize that it is a product of two functions, u equals 4x squared and v equals cos 5x minus 2. Since this is a product, we apply the product rule, which states that the derivative of uv is vu prime plus uv prime. First, we find the derivative of u, which is u prime equals 8x. Next, we differentiate v equals cos 5x minus 2 using the chain rule. The derivative of cosine is negative sine, so we get v prime equals negative sine 5x minus 2 multiplied with 5 equals to negative 5 sine 5x minus 2. Substituting into the product rule, we have dy over dx equals 8x cos 5x minus 2 minus 20x squared sine 5x minus 2. For question B, to differentiate the function y equals 3x plus 1 over sine 2x, we use the quotient rule, which is applied when a function is expressed as one expression divided by another. The quotient rule states that the derivative of u over v is vu prime minus uv prime over v squared, where u and v are functions of x. In this case, we let u equals 3x plus 1, which has a derivative u prime equals 3. For v equals sine 2x, we apply the chain rule to find its derivative. Since the derivative of sine 2x is 2 cos 2x, we have v prime equals 2 cos 2x. Substituting into the quotient rule formula, we get the derivative of dy over dx equals 3 sine 2x minus 2 multiply 3x plus 1 multiply with cos 2x over sine squared 2x.
So for question 3, given that y ln 2x minus e power of 5x plus 3 equals to tan 6y, find dy dx using implicit differentiation. So step 1, we have to differentiate. It will be easier if we differentiate one by one. So first, y ln 2x, we will use product rule. So d dx y ln 2x equals to dy dx ln 2x plus y multiply with d dx ln 2x. When we simplify it, it will be dy dx ln 2x plus y over x. For the second one, e power of 5x plus 3, we will use chain rule. So d dx e power of 5x plus 3 equals to e power of 5x plus 3 multiply with d dx 5x plus 3 equals to 5e power of 5x plus 3. And for the third one, tan 6y, we will also use chain rule. So d dx tan 6y equals to second power of 2 6y multiply with 6 and multiply with dy dx equals to 6 second square 6y multiply with dy dx. And then we are moving on to step 2, which is we will combine and solve the equation. So dy dx ln 2x plus x over y minus 5e power of 5x plus 3 equals to 6 second square 6y dy dx. So the whole differentiation part will substitute into the original equations. Next, group dy dx in one side while the others will be the other side. So it will be d dx ln 2x minus 6 second square 6y equals to 5e power of 5x plus 3 minus x over y. So the final answer will be dy dx equals to 5e power of 5x plus 3 minus x over y over ln 2x minus 6 second square 6y. That's all.
Hello, my name is Nur Abiatul Ain, and I will be doing question 4. For question 4, use linear approximation to estimate the value of cube root 63.98 minus 2 over square root 63.98. This is the solution for question 4. We have fx equal to cube root x minus 2 over square root x. So we have x equal to 63.98. For the first step, we have to find delta x by using the formula of x equal to x naught plus delta x. We have x equal to 63.98 equals to 64 plus delta x. 63.98 minus 64 equals to delta x, and we have negative 0.02 equals to delta x. Next, we have to derive the fx. We know that our fx is cube root x minus 2 over square root x. Then we have x power of 1 over 3 minus 2x power negative 1 over 2. Okay, and then we have to find f prime x equal to 1 over 3x power of negative 2 over 3 minus x power of negative 3 over 2. Next, we have to find the value of fx naught. We have to sub x naught into x, so it became f64 equals to cube root 64 minus 2 over square root 64 equals to 15 over 4. And then we have to find f prime x naught. Then we got f prime 64 equals to 1 over 3 multiplied by 64 power negative 2 over 3 and then minus 64 power of negative 3 over 2. Then we got the total of 29 over 1536. Lastly, we have to use this formula and then sub x into this formula. And then we got approximately equal to 15 over 4 plus 29 over 1536 multiplied by negative 0.02. And then we put back the question, which is cube root 63.98 minus 2 over square root 63.98, and then we got approximately equal to 3.750. So this is our conclusion. In this assessment, several key techniques of differentiation are applied, including the chain rule, quotient rule, trigon differentiation, and implicit differentiation. These methods are used to solve problems, including composite functions, ratios of functions, and equations with trigon and logarithmic expressions. Additionally, linear approximation values is employed to estimate values based on the derivative.